Good morning, Math 6. Today we are going to look at Wednesday, April 8th, and our assignment for today. So we're going to start getting into our math. We're going to take some notes today, and then we're going to do a whole group practice. But there will be nothing that you need to submit back to me today. So go to your attachment, get the document, put it in Notability. Now go over to Notability, create new note, import, open. Document we're going to work on today looks like this for Wednesday, April 8th. Today our objective, we're going to be able to substitute a variable to solve an expression. So the first thing you can do is take a little time to find the 10 differences in today's image. Again, this is just kind of our opener that we did in class together. I thought it'd be fun for us to continue while we did distance learning. Nice spot is that you don't have to share the whiteboard pen with anyone else, and you can find all 10 differences by yourself. Today, what we're going to look at is, what is an algebraic expression? There is no equal sign, okay? There is and you're going to have to write this word in, variable. If you're wondering how to spell it, I have the word right here again. So there is a variable. The variable in math, we call it a variable. It's an unknown number. Let me get my pointer. A variable is an unknown number. And in place of it, we use a letter. So it's when we don't really know what is going to be there, we're trying to solve for it, and we're going to use a letter. So when we do it with expressions, it'll tell us what should be in place of that letter. So we're just going to substitute. We're going to do some example problems. So for this first one, 8 plus k, and they told us over here, k equals 7. So I can just go ahead and in place of k, write the number 7. I'm going to rewrite the whole expression. 8 plus 7, and then I can tell what the answer is, and 8 plus 7 is, hopefully you said 15. All right, next one. So v is 5, so if I rewrite this, instead of v, I'm going to have 5. And remember, this symbol means division. So 20, if you want to rewrite it so you're more familiar with how it looks. 20 divided by 5. And then if I solve for 20 divided by 5, I can count by 5s. How many until I say 20? 5, 10, 15, 20. My answer is 4. Next example problem, in place of h, we're going to put 3. So remember, when a number and a letter is squished together, there's an invisible little time symbol between them. So instead of h, I'm going to have 3. And what I'm really asking is 4 times 3. And 4 times 3. Again, you could count by 3s, and we have 4 of them. So 3, 6, 9, 12. 12 would be our answer. So expressions are pretty easy when they're just straight up expressions. What we're going to also get into is expression tables. And that's being able to find a pattern and figure out what the pattern is to solve the table. All right, so for this table, the example that we were given, is to tell how many lines make up each of the figures. So if I look at this first figure, and if I was to, I'll pick a different color, figure out how many lines they used to make it, 2, 3, 4, 5, then in my table I'd say for figure 1, it took me 5 lines. All right, now for figure 2, I'm going to go ahead and count. These are each separate, so 1, 2, 3, 4, 5, 6, 7, 8, 9. For figure 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So expressions help us predict what's going to happen to other numbers that we don't have. So we don't have figure 4 and figure 5, but we could try to draw them based on the pattern we see above. So if I was to make figure 4, I'm going to start with figure 3, which looked like this. And I would add in another one. That's what I predict figure 4 would look like. So now I can go on figure 4 and figure out how many lines it took. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So figure 4 took 17 lines. Now I can make figure 5. So in your notes right now, you should be making your own. I'm going to go ahead and count how many there are. 1, 2, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So figure 5, I have 21. Okay, the next thing I asked you to do in the notes then is to complete the table, which we did, so we can check that off. That's all done. And then we need to figure out what's the number pattern. How do these numbers increase each time? And sometimes we can go this way and say, well, if I go from 5 to 9, I added 4. 9 to 13, I added 4. 13 to 17. And 17 to 21. So each time I added 4. That's a pretty easy pattern to see. There's a harder pattern to see that's happening too, and that's when we look at from the top to the bottom. How did we get from 1 to 5? And sometimes this takes a little trial and error. And we might say, well, I had 1 times 5 gave me 5. But we need to check it with more than one of them to see if that's true. Because if I have 2 times 5, I should have 10. And I don't have 10, I have 9. So that doesn't work. So I'm going to try, well, let's try this one. 1 plus 4, that gave me 5. But if I did 2 plus 4, because it's got to be the same pattern in every box, 2 plus 4 would only give me 6. So again, that one doesn't work either. So I'm going to help you out on this one. This one's a little trickier because there's 2 steps. So what's really happening is I have 1 times 4 plus 1. So whatever this number is, times 4 plus 1. So we'll see if it works for 2. Can I take 2 times 4? 2 times 4 is 8 plus 1. I get 9, so that one works. 3 times 4, 12, plus 1, 13. 4 times 4, 16, plus 1, 17. That one works. So it's always good just to check and make sure that it works for each of them. 5 times 4 plus 1. 5 times 4 is 20, plus 1, 21. So the pattern that's happening in this table is we have x times 4 plus 1. So I can use this pattern, like if we didn't know and we wanted to say what would happen if we had figure 17. I could plug that in then and say, well, 17 times 4 plus 1. And that would tell me what the answer is.